When discussing object-oriented programming, we often come across the term polymorphism, which of course is Greek and stands for many shapes or many forms. To see what this actually means in this context, remember that every class defines a data type, and therefore subclasses define subtypes. This means that you can bind an object of the subclass to a variable that is declared only to be of type superclass. So for example, we have these classes shape and subclass circle. Every circle is a particular shape, and therefore we can assign to a shape variable an object that is in fact a circle. This is what we do here in line 1. We declare a variable of type shape and initialize it with an object of type circle. So henceforth, we can treat the variable s simply as a shape, and that's fine because a circle is a particular type of shape. Since shapes have colors, we can write to the public attribute called color in line 2. But remember that shapes do not have a radius, and therefore line 3 here will fail because s is only known to be a shape. So line 3 doesn't work. The magic happens in line 4. We call the toString method on the object which is bound to the variable s. And since s is a circle in this case, the toString method of the circle class will be called and not the toString method of the shape class. Let's assume that we have defined constructor methods for the circle and triangle classes that just set the color attribute. This way in lines 1 and 2, we can declare and instantiate objects C and T, which are circle and triangle. Now, in line 4, we will declare a new variable s, which is a shape, and initialize it to the circle object C. In line 5, we then output this object s. Implicitly, it will call s.toString, because that is what the Java compiler does to turn a given object into a string. Now in line 7, what we do is we reassign the variable s, which is the shape, to t, which is a triangle. And that's fine because t is also a shape, and the compiler cannot complain. Finally, in line 8, we simply print out the object s one more time. Notice that the code in line 5 and 8 is exactly the same, but in line 5, s refers to a circle, and therefore the toString method in circle is invoked, whereas in line 8, s refers to a triangle, and therefore the toString method in the triangle class is invoked. This is a demonstration of polymorphism because s can have many forms. It is a shape, but there are different types of shapes, triangles, circles, squares, whatever, and they might all have their own different behaviors. As a final example, let me mention typecasting, and that is the situation where you want to make sure that the compiler understands that an object is an instance of a particular subclass and not of its superclass. For example, in line 1 here, we create a new circle and associate it with a variable that is declared to be a shape. So that's fine, that works. Now in line 2, we declare a new variable of type circle and want to associate this previously created circle to it. And that is not fine because s is known to the compiler only as a shape, and not every shape is a circle. But we know that s is a circle, and therefore what we can do in line 3, we tell the compiler by prepending the object by the name of the class in brackets that it is indeed a circle, and therefore this term can then be used to instantiate a variable of type circle. And this is called typecasting. Typecasting means you tell the compiler that an object is of a special subclass and not of a superclass.